Okay, so I'm going to take a look at this question here. Cam has 46 meters of fencing to enclose meditation grounds, rectangular, fence on only 3 sides. So I draw a rectangle that's only got 3 sides. And then what I do is I always take the one dimension that's repeated and I just give it a variable. I'm going to call it x. Okay, so if he has 46 meters altogether, then the question is, what does he have left for this length here? Well, he has 46 altogether, but he has to subtract the parts he's already used. If x is 1, he subtracts 1 and 1 again. If x is 5, he subtracts 5 and 5 again. No matter what, he's subtracting the x twice. So we have 46 minus 2x. From here, it's actually not too bad. So we've got area. We write the area because we're going to maximize the space, and that means maximize the area. So we do the area of a rectangle, even if it's only on 3 sides, is the length times the width. I always put the x first. It's just a little bit cleaner that way. And there we go. We have an equation here, and this gives us, this is factored form kind of. It's a bit funky looking, but it's kind of a factored form. And what we can do, we have a few options. One option, we can expand through the brackets, and then we could rearrange. Sorry, I don't know where 42 just came from. It was 46. And then we could complete the square, like we did before. But I think a much better method is to find the zeros, go halfway between to get the axis of symmetry, and then sub that in to get the y value of the vertex, because if we're looking to maximize, right, the maximum value of a parabola is always at the vertex. So the equation is broken into 2 parts. And the question is, what can I plug in here to make the whole thing turn to 0? And the answer is 0. And then here, what can I plug in for x to make this all turn to 0? Well, we want 46 minus 2x to equal 0. I add 2x to both sides. I divide by 2, and I get 23. And then the axis of symmetry is going to be 0 plus 23. I just add up the zeros, divide by 2, and I get 11.5. So then the max value, or the y value of the vertex, is going to be 11.5 times 46 minus 2 times 11.5. Oh, you know what? We don't even have to actually do this. It doesn't ask us for the max value. It asks us what dimensions will give the max value. So what we've done here by finding the x value of the vertex is we found the x value that will maximize this. So that means that this is 11.5. This is 11.5. And then to find the length, or the longer side here, you would do 46 minus 2 times 11.5, which I believe is going to be 23. Or you could take 46, subtract 11.5, subtract the other 11.5, and you're going to get 23. So it would be 11.5 by 23 meters. And that's it. Again, the key here is that maximum tells us we're looking for the vertex. Because the equation is a equals, our y value of the vertex would be our a value, that would be the area, but they want the dimensions, so we're looking for the x value, and once we have the x value, we sub in here to get the length, and we already have the width. And that's it. Let me know if that clears things up.